This week, we'll learn how to use some magics in the notebook to find where in your code is slowing you down with profilers. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to continue looking at some notebook tips and tricks that you may not know, and we're going to talk about profiling your code. So we're going through a lot of useful things from extensions for notebooks to profiling, and eventually we'll get to using debugging in the notebook. So I've written some code here that we're going to go over, and then we're going to find out what's slow. At the top, of course, we have our block of imports using matplotlib, numpy, MetPy's calculations, MetPy's units. I'm importing sleep from time, and we're using the matplotlib inline magic so our plots show up in the notebook. Now you're probably thinking that I'm going to use sleep to slow code down, which you're right, but I think we're going to see some interesting results from the profiler. Next, I've got a function called generate UV data. So this generates uniformly distributed U and V when data. You tell it the number of data points that you would like. The default is a low and a high, minus 15 to 15. And we're going to use NumPy's random uniform distribution to get a number in this interval, inclusive on the low end, exclusive on the high end. And we're going to assign it units of knots. Notice I went ahead and put a sleep 1 in there. So we're going to wait 1 second before we return any data. This could be simulating some long time to read data from a text file or whatever else you've got going on. Next, we've got a function workUpData that takes U and V, and we're going to use MetPy's calculations to return wind speed and wind direction. So nothing too out of the ordinary there. Then we're going to plot the data. Speed and direction are what we put in. We create a figure with 2 axes, and we plot speed on one and direction on the other. And finally, we've got this sort of a wrapper function, but a function that you often have in your research code that says, do my data processing. So it does all of the steps. It puts all of these function calls together. We generate our data, we work up that data, and then we plot that data. Okay, so I'm going to run the rest of these cells. Okay, so first let's try using do my data processing and just make sure all of our code works. So we're in our research mode, we're processing data, and that worked great. That's the plot that we want. Except now we're going to have to do this for 100,000 model runs or something where this becomes important to know where are the slow parts and what can I work on. Often you'll spend a lot of time blindly optimizing code only to find out that you've been optimizing something that takes maybe 10% of the time. Whereas you could have looked at a different section of code that you didn't think about and cut out a lot more time with potentially even a lot less effort. So we've talked about using profilers a long time ago on a MetPy Monday, but we haven't talked about using them in the notebook, and since we all do our development in the notebook, this is a fantastic thing to know how to do. And once you see how simple it is, just like using TimeIt, which is a sort of profiler, we can do it all the time. So let's look at the simplest way to do this first. I'm going to use a magic prun do my data processing. Now we run that cell, and we get our plot, but we know it took 5.071 seconds. We had about 10.6 million function calls, and of those, about 10.4 were primitives. It's ordered by internal time by default. And now we can start looking down, okay, here's the number of times a function was called, the total time we spent doing it, per call time, cumulative time. So let's see. First, we've got our sleep method. We spent 1 second in one call to it. Down here, though, from quantity.py, we're creating a new quantity. Look at that. The cumulative time was 1.6 seconds. Or further down here, using 2, so we're doing some unit conversion here, 2.035 seconds. Convert value in matplotlib, 2.8. So there's a lot going on here. Now, unfortunately, this is a huge stack of things to look through, and that may not tell you, okay, well, I can't reduce the number of times that 2 gets called easily, probably, without digging into some lower level code. So prun is a great tool, and you can do some more sorting with it. So for example, you can specify different columns to sort by. You can always do a prun shift tab and look through here so we can limit. Okay, sort, that's what we want to do. What do we want to sort by? I want to sort by cumulative time. So cumulative. Now we run that again. And now we have a cumulative time sorting. All right, so that's using prun, but it's not the one that I find the most useful most of the time. I like using line profiler. If you don't already have it installed, we can do that. Normally you could go to the command line, but also remember an exclamation point in the notebook is going to be like running that command on the command line. So I just pip installed line profiler. Great, now that we have line profiler installed, we need to load that extension. So loadxt line profiler. And now we can go ahead and use it. LP run, line profiler run. I want to profile a function line by line. That function is do my data processing, and then I'm going to call do my data processing. And once that runs, we're going to see our plot, total time, and then a line-by-line profiling. So generate UV data, which has the sleep in it. We're sleeping a whole second there, is only 17.7% of the time. The workup data is 0.1%, and plotting is 82.2%. So if we had anything to do, we could do it in plotting to save ourselves a lot of time. Well, what in plotting is slow? Is it creating the figure? Is it plotting data? Is it adding axes? Let's look at what's going on in there now. So I'm going to go back up here. I'm going to say I want to profile plot data and call do my data processing. So I profiled plot data and called do my data processing. We've got our graph, our time, and oh, look at that. All of the time almost is spent in the actual plotting step. So what could we do? Well, we could decimate our data, but let's do another experiment. I'm only going to generate 100 data points. Now let's go down and LP run again. Okay, so now it's totally different. Making this first subplot takes all of the time. What if we look at do my data processing again now instead of the profile? Oh, yep, now 92% of the time is taken by generate UV data, which is going to be our sleep. So the reason I show you that is it can depend, you need to profile doing a real world type processing problem, because if you just generate, a little bit of fake data, it's not going to respond the same. Your profiling results are not going to be useful. All right, so now let's go back. Let's plot a bunch, rerun our profile. Okay, now we're back to the plotting taking most of the time. Well, you're not going to be able to see that many data points on a monitor, especially in this little bit of space. So what if I did something like decimate by a factor of 100? Okay, now let's go run our profiler again. Okay, I might or might not still be able to get the same amount of information out of my plot, but now I'm getting a more even split between my lines of how long it's going to take to do each of them. So I've optimized away a lot of that time there. Profiling is an art for sure, but using tools like prun and lprun, and especially being able to run them in the notebook as you're developing and playing with your code, really let you make programs that are faster and more efficient with just a little bit of effort. I hope that you found this useful, and I'll see you on next week's MetPy Monday.